How do you add relational database support to your Spring application? We'll see how to use Docker to spin up local instances of Postgres, how to map classes to tables, and finally how to provision Postgres database in the cloud and connect it to our Spring application. We'll also explain object relational mapping features of Jakarta Persistence API, JPA, with special attention to relationship annotations like one-to-many and many-to-one. This tutorial is part of multi-part series where we develop secured Spring application with social login, but you can follow this tutorial independently as well. Let's remind ourselves what is the current state of our application. We have secured web app with publicly accessible homepage and the ability for our users to log in via Google and Github. We also have the ability for our users to register with their custom user. The problem with our app is everything is happening in memory. Nothing is saved. We'd like to correct that by persisting our data in relational database. Relational databases have long been on the market and have reached maturity and reliability levels that makes them prime contenders for small, medium and large businesses. We've chosen PostgreSQL for our database management system. What system you choose might depend on what you are familiar with, but our reasoning primarily was availability of PostgreSQL as an option on various cloud providers. Our simple app could run on every other popular DBMS option as well, with minimal changes. In order to add database support to our app, we'll need to have database running locally and we'll need to add support for working with databases to our Spring app. The easiest way to have local instances of database running is by using Docker and Docker Compose, and we'll use official PostgreSQL image. And as for version, it's best to synchronize with what your production is running on. As a showcase in this session, we'll provision a database on Railway.app, and they have database services using Postgres 13 version. So we'll use that version for our local instance as well. If you search PostgreSQL on Docker Hub, you'll find the Docker official image, and they have the example of Docker Compose file, which we'll use as well to start up our local instance. So we'll copy their example. We'll go to our application and create Docker Compose YAML file and paste in the example from the official site. We'll change a few things. We'll up the version to latest as of this recording, which is 3.8 of Docker Compose file, and we'll base our container on Postgres 13 image, as we've discussed earlier. We'll also need to expose ports. That is port 5432 that Postgres runs on by default, so we can access the database from outside. And besides Postgres password, we can find additional environments, variables that Postgres exposes for us, and we'll use them. We'll use Postgres user and Postgres DB. Docker Compose can read environment variables from .env file, and you do that by using $curly braces syntax, and let's say we'll call this one dbpass, and you can provide default values by using :- syntax, and then let's say pass will be default value for our password. We can do the similar thing for our user, and we'll call this dbuser. And for database, we'll call this environment variable dbschema, and let's call it ss2c for Spring Social to Cloud, and let's reorder them a bit. Since we provided default values, we can, but we don't have to specify anything in our .env file. If you need to, you can override those default values by doing so. We can add environment variables in .env.example file so other developers are aware of what's available. dbschema is the place where Postgres will save our tables and sequences and data, etc., and user and password is what Postgres will use to connect to our database, to our schema. Now that we have our Docker Compose YAML file ready, we can start our database instance. First, you need to make sure you have Docker installed locally, and then we can start our instance by using Docker Compose up -d for detached. If you don't have Postgres 13 image locally, it will first have to be pulled from the Docker Hub. I do have it installed locally, and that's the reason why the instance was created instantly. And we can make sure that everything is okay by running docker ps, and we see that the instance was created 14 seconds ago. I'll use dbeaver, that's a free tool for working with databases, to create a new Postgres connection. It will be to our local host. Our database was ss2c spring social to cloud. Username was user and the password was pass. And we can test the connection and create it. And just to make sure, there are currently no tables, views or anything. Our database, it's empty database. To make our Spring app connect to the database, we'll need to add database support in a Spring ecosystem. And if you're not familiar with what's available, I've created a little video to help you out. And for now, we'll add Spring Data JPA and PostgreSQL driver support. We'll explore the project and copy the two dependencies we need and paste it in our POM XML. We can reload our project, and if we start our application, we should get an error because we've added the database dependencies and we didn't specify URL attribute or username and password that's needed to connect to the database. So we can go to our application properties, and similar as in our OAuth2 login, we'll provide DB credentials and we'll provide DB URL, DB user and DB password environment variables that user can set up. And if they are not available, we can provide default values. And you do that a bit differently in application properties than you do that in Docker Compose YAML file. In Docker Compose YAML, it's :-. In application properties, just colon for default values. And that should be enough. If we start our application now, the default URL, user and password should be found and the application can start. Properties you need to specify in application.properties in order for Spring application to connect to relational databases are Spring data source, URL, username and password. And we specified environment variables because when we deploy our app to Railway.app or some other cloud providers, we'll use different URL. URL we get from provisioning databases through their services. During the development phase, it's a good opportunity for me to showcase certain JPA features. And I'll have JPA create and drop tables for us. And we'll create another application properties file, application dev properties, and we'll place certain properties that we wouldn't use during the production. We'll show SQL, we'll format it so it looks nice so you can see what the JPA is doing, and we'll have Hibernate, which is our JPA default provider, create and drop tables as we go along. I'll activate the dev profile by setting up the environment variable Spring profiles active and setting it to dev. Apply, OK, restart, and we'll see that the following profile is active, dev. That means our application dev properties is taking effect besides our normal application properties. We've added database support to be able to store our user information. A little overview of our database schema. We'll have three tables: users, authorities, and intersection table between them, user authorities. User authorities will store information which user has what authority. To deal with data and persistence in our application, let's first create data sub-package under security package. To map database tables to Java objects, we'll use Object Relational Mapping, ORM, features of the JPA, of Jakarta Persistence API. Let's start by mapping our user entity. And we'll create a new class, call it user entity, We'll mark it with entity and table annotation. And we'll provide a mapping for our relational table name. It's practice for Java classes to be in singular and for tables as they contain a rows of data to be in plural. So we'll say that the table name will be users. To have getters toString hash code in equals generated for us, we'll use Lombok data annotation. And in order for JPA to work, it needs to have default no-R constructor. And we can set the access level to private, since it will only be used by the JPA. Entities need to have ID column, so we'll say that our string username is the ID. And we'll also have other fields: password, email, name, and image URL. We'll also have login provider. It's app, Google, or GitHub. We'll call the field provider. And it's an enum, so we need to say that we need to map it as a string, not as an ordinal. In order to do that, we'll say it's enumerated and the value is not ordinal, it will be string. So in the column it will be app, Google, or GitHub. Java uses camel case naming scheme, and database objects are usually named with snake case. So in order to say that image URL column should be called image_URL, we'll use @column annotation and provide name value and say that the name of the column should be image_URL. JPA provides automatic naming conversion, but it's a good idea to provide explicit one as well. If we restart our app, since we are on the dev profile, we should have the table automatically created, since we specified our properties for drop and create. And we see drop table if exists users cascade and create table users with the fields we specified. If we go to our dbeaver and refresh our tables, we'll see our users table created with the fields we specified. In our user entity, besides the fields that correspond to our app user, it might be interesting to also have a field that tracks when the user was created. So we'll create additional local datetime created at field, and we'll mark it with a column name created_at. And we don't want to fill this column ourselves, we want it to be populated automatically, and JPA offers pre-persist annotation that will do that for us. So we'll call the method assign created_at, and we'll say that this created_at is local datetime now. Let's create an entity class for our authorities as well. We'll call it authority entity. It will also be an entity, table, name will be authorities. It will have data, Lombok annotation, and no-R constructor with access level private. It needs to have an ID column. We can make it long, and it needs to have the name of the authority. And we can also add the provider who was responsible for creating authority. For our user entity, we used username as a primary key, and it was generated by the user or it was given to us by our auth2 login provider. In the case of authority entity, we need to generate the ID ourselves, and we'll use the sequence for that. Let's add a generator for our authority entity ID. So we'll say it's generated value, and this alone would work. So if we restart, we'll see what will this generate. If we go up, we'll see that Hibernate or created authority sequence automatically for us. Sequences are concurrency mechanism for assigning IDs in databases like Postgres and Oracle. As soon as you insert, they fire and generate a new value, and you no longer care if your session commits or rollbacks. Your IDs won't clash with other session IDs, as sequence will generate special ID values for them as well. Although generated value would work as is in our case, let's make this explicit. So we'll say that the strategy is sequence, and we'll need to provide a generator. We'll say that it's authorities ID generator. And we'll need to provide another annotation for sequence generator. And name needs to be the same as in our generator, in our generated value. So we'll copy that afterwards. And sequence name will be the physical sequence name in our database. So we'll call this authority sequence. And these two, generator and sequence generator name, need to match. We also have allocation size. Default is 50. So let's just discuss what that is. I'll say 5. I'll change it to 5. Allocation size is JPA's way to reduce network round trips when batch inserting rows. It will behind the scenes generate sequence that will increment by 5, so our persistence provider doesn't have to contact database for our next 5 inserts to get the primary key value. Since our generator and sequence generator name are related to our Java objects, let's rename them to singular authority ID generator, because that's the practice for naming Java objects. And let's create our final entity, user authority entity. So we'll create another class, user authority entity. It will also be an entity table with the name of user authorities. It will also have Lombok data annotation and no R constructor annotation. Access level private. And it will have an ID column, also long ID, that will be, as well as in our authority entity, it will be a generated value. We'll just leave it as is. We saw that Hibernate generates the correct thing for us. Next, we'll need to tell JPA about relationships between our entities. And we'll start with user authority entity, which is an intersection table, so it has connections both to user entity, which we'll mark by creating a field user, and authority entity. We'll create a field of authority. We'll go to our user entity, and we'll need to say that a user can have a list of authorities assigned to them. So we'll create a list of user authority entity. We'll call it authorities, and it will be new array list. And we'll go to our authority entity. It can also have a list of user authority entities. We'll call it assigned to. We'll call the field assigned to. And also it will be a new array list. So this will be authorities that user authority entities that authority has been assigned to. Creating fields is not enough. In order for JPA to be able to construct object graphs, we'll need to annotate our fields with annotation that describe what kind of relationships these entities have between them. These are notorious one-to-many, many-to-one, and many-to-many annotations that seem to cause confusion, so we'll take a bit of time to explain them. Crow's foot notation is a way to represent entities and their relationships. Entities are represented by a rectangle with its name on top, and relationships between entities are represented by a line connecting them. Relationship line has two additional properties to represent cardinality and optionality of the relationship. Cardinality tells you maximum number of times instance of an entity can be associated with instances of other entity. Possible values are 1 and many. Many being represented with something that looks like crow's foot, where the name of the notation came from. Optionality tells you is connection between lines mandatory, represented by 1, or optional, represented by 0. By combining these two, you can tell more about the nature of the relationship. On top, we have optional 0 or 1 and optional 0 or many relationship. And on the bottom, we have example of mandatory 1 and only 1 relationship and mandatory 1 or more relationship. Let's look at examples. You usually add verb to relationship to add meaning. Student occupies 1 and exactly 1 seat. Seat is taken by 0 or 1 student. Lecturer can teach many but doesn't have to teach courses. And course is given by exactly 1 lecturer. You can have many-to-many relationship as well, as in student-course example, but they are usually a sign you're missing some domain concept, and can be solved by introducing intersection table where we split one many-to-many relationship to two one-to-many relationships. In student-course example, we can introduce attendee entity, which would give us ability for a student to take the same course multiple times and a place where we can grade each attempt. Entity relationships of our user and authorities is similar to those of student and courses. User can have 0 or more authorities assigned to them, and authority belongs to 1 or more users. A row in a user authority table belongs exactly to 1 user and exactly to 1 authority. If we have a look at the example data, we'll see that the user Bob has read authority and user Bill has read and write authority. A row in a user authorities belongs exactly to 1 user and exactly to 1 authority. But multiple rows in user authorities can belong to the same user. In this case, Bill has read and write, 2 rows, and multiple rows in the user authorities can belong to the same authority. In this case, 2 rows belong to the read authority. And this is an important point about Java relationship annotation. You reason about them by looking at your entity relationship diagram and the shape of your data, not by looking at your Java application. Let's get back to our Java app and mark JPA relationship annotation. We saw that user can have many authorities, as in Bill had read and write authority. And we'll mark that by saying one-to-many. One, this first word is related to the current class we are in, and the second word is related to the relationship. So one user, in the case of Bill, can have many authorities, like read and write. Similarly, for our authority entity, authorities that authority can be assigned to is one-to-many. Read authority, we saw that it was assigned to many users, to 2 users in our example. A user authority entity has user entity and authority entity, and it's many-to-one in both cases. We had 2 rows in user authority, read and write, related to 1 user, Bill, and in a similar fashion we had 2 rows, 2 read rows related to 1 read authority. So many rows from user authority are related to 1 row in user or authority. Since our user authority table will have foreign keys for both user and authority, we can mark that by providing join column annotation and giving it the name of the column that will be a foreign key. In the case of user, it will be a username, and in a case of authority, it will be authority ID. We can also mark how the foreign key constraint will be called. So we'll provide foreign key value and we'll say that the foreign key annotation, that our name for the foreign key constraint will be, in the case of authority, user authority, authority foreign key, and in the case of our user foreign key, it will be user authority, user foreign key. Next, we'll need to mark the other part of the relationship, and we'll do that by copying the field name from our user authority entity and saying in our authority entity that in our one-to-many relationship, that relationship is mapped by the authority. This name needs to match field name in user authority entity. And similarly for our user entity, we'll say that in our one-to-many it's mapped by user field. In our application, we'll manage a relationship of user authorities primarily using user entity. We are currently not interested in other part of the relationship. What are the users that have read authority, let's say. So anytime we insert, change or delete a user, we also want to cascade to user authorities related to that user. And we'll do that, we'll mark that by using cascade type all. Another thing that doesn't make sense in our application is to have user authority that doesn't have a user assigned. So we can mark that by saying orphan removal to be true. In other words, if user name is removed from the user authority row should be deleted. While we are at the topic of relationship, I'll need to mention that Lombok toString does not play well with JPA. If you try to output user bill, it will go through its authorities, find read authority, and then try to toString authority entity and try to output all the users that have read authority. And the infinite cycle would start again and your application would break. In order to break the infinite cycle, we'll go to user authority entity and mark fields to be excluded from Lombok toString generation. And we'll do that by using toString exclude on both fields. That's it for our JPA relationship annotation. We can restart our app now to see what will Hibernate create for us. Drop and create what sequences and what tables. And we see we have authority sequence and user authority sequence created, authorities table, user authorities table, and users table. And also 2 foreign keys on user authorities. Nice. Since user authorities will be handled over user entity class, we'll need to create 2 helper methods that will enable us to add and remove authorities to a user. Let's first create constructors we could use for our entities. For our user entity, we'll create a constructor that will take in everything except created at and authorities. For our user authority entity, we'll create a constructor that will take in user and the authority as a parameter. And for our authority entity, we'll create a constructor that will take in the name and the provider as a parameter. Let's create method for adding authority to a user. And maybe a better name for a field is user authorities, not just authorities. So we'll rename that. And we'll create a method for adding authority first. We'll take in the authority entity, and first we'll need to create new user authority entity that takes in the user and the authority. The user will be this, and the authority will be given authority, and we'll need to add it to user authorities of the user, but also to assign to list of the authority entity. So we'll create variable user authority and we'll add it to user authorities, and we'll also add it to a list of assigned to authorities of the authorities. So we'll say authority get assigned to and add user authority. And we'll only add the authority if the user authority doesn't already exist. So we'll need to check. So we'll say user authorities stream if any match user authority entity, if any match that get user is equals to this user and that get authority is equal to given authority. So if any match, then we'll just return. We don't need to add the authority. Otherwise we'll do what we've done. For our remove authority, we'll be given authority we need to remove from user authorities list. While we iterate over a list and compare it, is it equal to a given authority. So The way we can safely remove an item from the collection while iterating over it in Java is by using iterators. So we'll create a method remove authority. We'll be given authority entity, and first we'll need to get a hold of the iterator of user authorities list. So we'll say user authorities iterator, and while iterator has next, we need to get a hold of the current element by using next. That will be our user authority entity, and we'll need to check if next get authority is equal to given authority. If that's the case, then we'll need to remove it from the user authorities list. So we'll do that by saying iterator remove the current element, but we'll also need to remove it from the assigned list of the given authority. So we'll say authority get assigned to and remove next. And we'll also need to set our user and authority of our user authority to a null value, because we want to let the JPA know that this row should be deleted. So we'll say next set user to null, and also next set authority to null. And that's it for our remove authority method. Next, we'll need to create repositories for our user entity and our authority entity. Repositories are Spring Data abstractions for accessing persistence provider. Repositories will enable us to save, delete, and fetch entities. So first we'll create user entity repository. It needs to extend, we'll say CRUD repository of user entity and string as an ID. Although technically it's not wrong to mark this interface with @repository, it doesn't do anything because repository as a stereotype annotation only works for classes. So we'll get a bean of user entity repository automatically by extending CRUD repository. JPA framework will take care of that. And by extending CRUD repository, we'll get a host of methods like find by ID, save, delete by ID without writing a single line of code. So that's a really powerful abstraction. Let's see who else implements CRUD repository in the framework. And we see a list CRUD repository, which is a repository that instead of iterable returns a list. And we also see JPA repository. Now, interesting thing about JPA repository, it extends list CRUD repository, but also list paging and sorting repository and query by example executor. You can use paging and sorting repository well for paging and sorting. When you have a fixed amount of items you display on a page, and this will give functionality to know whether there's a next page, how many pages are there, and are you on the last page, and the ability to get the first and the previous page. Query by example executor is useful when you have, let's say, a list of products and a filter, and the user can select certain attributes of your item, and the framework will automatically generate a query that will satisfy the given attributes. In our application, we don't need this advanced functionality, otherwise we would extend JPA repository. For our needs, normal CRUD repository is enough, so we've extended CRUD repository. Next, we'll also create repository for our authority entity. So we'll create a new interface, authority entity repository. It will also extend CRUD repository. And the first parameter is the entity, so this is authority entity, and the second parameter is the ID of the entity. In our case, it's long. And that's it for our authority entity repository. Next, we'll need to use our repositories in our app user service, and we'll need to replace our in-memory users with the users from the real database. Some of our methods in our app user service will now have to be transactional, as they will deal with database transactions, and the way Spring handles that is by subclassing our app user service to be able to execute a method in a transaction. This means we no longer can use long getValue annotation because it makes our class final. Instead, we need to use addData and requiredArg constructor annotations. And addValue provided private final by default on our fields. We'll now need to provide them manually. And we'll also provide two fields for our repositories. So we'll say user entity repository and authority entity repository. Let's delete our user's hash map, and we'll go method by method and replace in-memory implementation with the one that uses database. For our load user by username, we'll now use user entity repository to find the user by ID. We'll give the username, or else we'll throw username not found exception. So we'll say throw new username not found exception. We'll say string format %s not found. And that will be our username. Our user entity repository returns user entity, and we need to return something that's compatible with user details. So we'll say we'll map our user entity to, let's say, app user builder build. And we'll fill in the fields. We'll say that the username is user entity, get username, password is user entity get password, name is user entity get name, image URL is user entity get image URL, and we'll need to fill in the authorities as well. So we'll do that by accessing user entity get user authorities. We'll stream and map those to, we need to map those to simple granted authorities. So we'll say stream map for each authority. We need to, for each user authority, we need to get the authority and get the name, and we'll create new simple granted authority from that. And we'll need to collect that to list. And that's it. I forgot another field for the provider, so we can say provider is UA get provider. And maybe we can say user not found. And that's it. Let's go to the next method. Create user method. For our create user method, we'd like to insert the user and the authorities in the database if they don't already exist. We'll also need to check whether authorities given in the app user match what's in the database. First, we'll mark our method with addTransactional because we are dealing with database and we could potentially insert new data. And we'll get a hold of the user entity by saying save user if not exists. And we'll give in the app user we've been given as a parameter. We'll create the method and we'll say user entity repository find by ID user get username. If user exists, this will return a valid user. Otherwise, we'll insert a new user by saying user entity repository save new user entity, and the constructor takes in the parameter that will fill. So username, first parameter get username, then password, then email, then name, then image URL, and the last one is login provider. And that's it for our save user if not exists. Next we'll need to get a hold of the authorities user might have. So we'll say list of authority entities, authorities is equal to user authorities. We'll stream those and map them to authority entities. So we'll say for each authority, we'll save authority if not exists, we'll give it the authority name, and we'll also give in the login provider. We'll get a hold of the login provider from the user. And we'll need to create this method. It will return authority entity, and we'll say authority entity repository. We'll need to create new method, find by name, and we'll give in the authority. Let's create this method in authority entity repository, which will return an optional of authority entity, and the rest is fine. We'll give in the string as authority, that's fine. Import the optional, and let's go back to our implementation. So if we don't find it, we'll create a new one. So we'll say or else get, and we'll go to our authority entity repository, save, we'll create new authority entity, takes in the name, so that's the authority, and the provider as a parameter. And that's it. Next we'll need to connect our authorities to our user, and it could happen that some new authorities were added to the user and maybe some old ones were deleted. So we'll need to merge authorities together, and to accomplish that we'll create a new method in our user entity. We'll say merge authorities, and we'll pass in the authorities, and we'll create a method in our user entity. So it's fine, it should receive a list of authorities. We'll implement it next. First we'll need to find a list of authorities to remove, and this will be from our user authorities. We'll stream it and collect it to a list, and we need to filter in user authority entities that are not contained in the given authorities. So we'll say authorities contains user authority entity get authority. And these are the authorities we'll need to remove, so we'll just say to remove stream, not stream, we can use for each, and for each user authority entity we'll just say this remove authority user authority entity get authority. And we can also add a new one. We'll use authorities for each. We'll just use this add authority, and our add authority already checks does the authority already exist, so we won't double the authorities. And that's it for our merged authorities. We can get back to our create user. Since we possibly created new user authorities, we'll need to save that by using user entity repository and save our user entity. Let's go to our next method, delete user. So if user exists, we'll say user entity repository delete by ID username, and that's it. And the next method is change password. We'll comment out the old method just for reference, and we'll say user entity repository find by ID current user get username, and if the user is present, we'll change the password for our user entity. So we'll say set password, and the password will be password encoder encode new password. And we can remove the old implementation. Since this method changes database data, potentially changes, we'll need to mark it with @transactional. And the same for user exists, which we'll implement next. For user exists, we'll just say user entity repository exists by ID, username. And that's it. In our app user service, we had create hard-coded users method, which we plan to remove in the future. For now, we'll just remove it from our app user service, and we'll create a new service, let's say user creator service, which will be a service and Lombok value. We'll paste in the create hard-coded user method, and we'll have our app user service and our password encoder as fields. And instead of just calling create user, we'll call app user service create user. And in the future, we'll completely delete this user creator service, but we'll leave it for now to help us in the development and in testing. One other thing left to do in our app user service is to save user to the database when the signing happens via Auth2 or OpenID Connect protocols. Currently, we are just returning our app user. We won't call create user directly because signing already happened, so there is no need to delay the method by waiting for database inserts. We'll call create user on another thread to prevent that. To accomplish that, we'll use Spring built-in executor service, and we'll go to our Auth2 handler, and instead of just returning the app user, we'll assign it to a local variable, return it, but also try to save it. So we'll create a method save Auth2 user, app user, and we'll create a method, and we'll use completable future for create user to run in different threads. So we'll provide a runnable and say create user, app user, and we'll use an executor for this method to run in a different thread. And we'll need to do the same thing for IDC handler. We'll create a variable for our app user, and we'll use the method save Auth2 user. And that should be it. I need to mention that the executor service doesn't propagate security context, but in our case we don't have security context set up yet, so it's fine. If you do need to propagate your security context to your executor, there are various ways. One of the ways by using delegated security context runnable. Let's try to start our application to see what we have. First, we'll wait to see if our tables are created correctly, and it seems a couple of inserts fired to create our hard-coded users. If we go to our dbeaver and refresh our tables, we see 3 new tables created. If we go to our users table, we'll see Bob and Bill inserted and the read authority inserted. And Bob and Bill both have read authority. If we go back to our application, try to log in via, let's say, GitHub, and go back to our database, to our users table, we see our GitHub user inserted, and refresh our authorities, we see our GitHub authorities, Auth2 user and scope read user inserted. And if we try to log in via Google and refresh our users table, we see our Gmail user inserted. Refresh our authorities, we see our OIDC authorities and scope inserted. and our user authorities are correctly assigned for our GitHub and our Gmail user. Nice. So far we've let JPA drop and create tables for us, but of course we can't do that in production. We'll add a database migration tool that will help us create database objects only when needed. Spring offers first-class support for two database migration tools, Flyway and liquibase. And if you'd like to know more about how these tools work, you can check out the video I made on the topic. In this tutorial we'll use liquibase. So let's just explore what is the liquibase dependency, and we'll copy the dependency and go to our project and paste it in. And we'll reload the project so the new dependency gets pulled in. We'll see that our app fails to start after we've added liquibase dependency because liquibase expects our project to have changelog file with list of database migrations we want to run. Liquibase supports YAML, XML and JSON for its changelog file, and they have the same functionality, so it's a matter of preference. It also supports SQL, but only with limited functionality without support for external SQL files. I'll use XML. So let's go to our application properties, and we'll need to set up the property with which liquibase will find its changelog file. Spring liquibase change -log, and then we'll set it equal to db changelog XML. So we'll go to our resources and we'll create first directory db, then under that we'll create another directory changelog, and under that we'll create our file changelog XML, and we'll go to liquibase site. Here they have example of all file formats that they support. So it's XML, SQL, JSON, YAML, and we'll go to the example XML file, we'll copy the example, go to our application and paste it in. They have some example change set there. We'll just delete those and leave the empty file. And if we start our application, it now runs. In liquibase terminology, change sets are individual changes to the database we want to migrate. That will be our create sequence and create table scripts. We can define them in liquibase proprietary language or as plain SQL. We'll create plain SQL scripts and link them to our changelog file. When you link your scripts in changelog file, you need to watch out for order. In our example, we'll first need to create users and authorities tables before creating users authorities that has foreign key on user and authority. Let's first create our scripts for sequences. We'll go to our dbeaver and we'll go to the sequences part, and we already have a sequence created on our database, so we'll just copy the DDL dbeaver provides us. And in our application, we'll create a new directory schema, and we'll create our first script there. So file, authority sequence, SQL, and we'll paste in the script from our database. We don't need public. And that's fine. And now we need to link our script in the changelog file. We'll go to our changelog. So the first one will have sequences. And this will be our change set. ID doesn't have to be number. In fact, I recommend you put some semantic name in there. And you don't include numbers at all. Liquibase will take care of the order. So we'll say create sequence author, and we'll just include SQL file with a path, and our path is db schema. Since we'll have tables and sequences, maybe we can place it under subdirectory sequences. And we'll go to our schema, create another directory sequences, and place our authority sequence there. Let's do similar thing for our authorities table. So we'll go to dbeaver, find authorities table, find the DDL part, copy it, go to our application, create another subdirectory under schema, we'll call it tables, and create new file authorities table, authorities SQL, and we'll paste it in the script for DDL in there. Again, we don't need public, the rest is fine. And it seems we have a typo in there. That probably means we have a typo in our authorities entity. Let's see. Yes. Okay. And let's include the authority script in our changelog. So tables. Change set. Create table. Authorities. Author. Okay. It will be an SQL file as well. Path DB, schema tables, authorities SQL. I will repeat a similar process for our other database objects, and I'll be back once I do. I don't think you need to see me type in all of that. You got the gist. I've added 2 additional scripts for our tables and 1 additional script for our sequence. And we'll go to application dev properties. We'll comment out the create drop part because liquibase will create tables for us. And we'll go to our command line and we'll down our instance because we need to create a fresh instance so we don't have any tables as liquibase will create them. So we'll up again minus detached, and you see how convenient the Docker Compose is. You can drop and create instances in a matter of under a second. If we go to our dbeaver and refresh, we don't have any tables or sequences currently, and we'll start our application. And if everything works correctly, there it is, liquibase in a changelog provided us information that it created sequences and tables for us. If we go to our dbeaver again, we have our 3 tables and additionally database changelog table. This is the liquibase table that liquibase uses to track which migration it ran. And we see that our 2 sequences and our 3 tables have been created. And if we restart our application, liquibase will use this table to know that it doesn't have any new migrations to run, so it won't do anything. There we see it tried to find the migration it needs to run. It didn't find anything, it didn't do anything. And we still have our 5 migrations from the previous run. Just to note, we didn't specify any special username, password or URL for liquibase. It uses Spring Data Source URL, username and password to connect to our default database. Let's provision the database at our cloud provider, Railway.app. We'll go to our project and we'll click New, Database, Add PostgreSQL. That's all it takes to spin up new instance of the PostgreSQL. Once the instance is ready, we'll have the ability to check out instance settings, connect to it, issue queries, and check out the data. So the instance will expose database variables for us: database URL, host, password, port, and user. And in fact, this instance is publicly available, so we can use our dbeaver to connect to it. Let's use dbeaver to connect to our database. First we'll copy the host variable. We'll go to our dbeaver and create new Postgres connection. Next. host, then we'll copy the port, PG port. For port, we'll copy the database schema, that's PG database. We'll copy the username, PG user. And we'll copy the password, PG password. We'll test the connection. And it was successful, so we'll click finish. And indeed, now we have our Railway database connected to. Let's convince ourselves that indeed it is connected, so we'll create table drop me. We'll have a dummy column, let's say 20, and indeed table was created. If we go to our Railway interface, we see our drop me table, and we can drop the table. And it's gone. Let's use environment variables Railway exposes for the Postgres database to set up the connection for our application. We'll go to the variables tab, and we'll need DB user, and we can reference variables by using $ and curly braces. Our DB user will be PG user. We'll need DB password. This will be PG password. We need database URL. Now database URL needs to be jdbc :postgres : / then host name. So host name is Postgres PG host. Then we need to have : then port. Port is Postgres PG port, and then the name of the schema, that's PG database add. So again, let's have a look at the database URL, jdbc PostgreSQL host, port, and database name. That's fine. We should be set. I'll commit our changes and push them to our developer branch. After the push has been done, they should trigger the new deployment, and we'll wait for a second for our deployment to finish. Our deployment has finished. If we open deploy logs, we'll see that liquibase has ran its migration. That would mean if we go to our Postgres, we should see the tables, authorities, user authorities, and users. And in users, we should see our Bob and Bill. And if we open our application, try to log in via GitHub, log out and log in via Google. And if we go back to our Postgres database, check our users out, there are our two users from GitHub and Google. And if we check our authorities, we have our Google and GitHub authorities. Nice. Currently our application is brittle. If we run Maven test, the test should pass. That's only because we have our local instance of Postgres running. If we shut down our instance with Docker compose down, our test will fail. So let's do that. Docker compose and if we run our Maven test again, our test fails. So that's something we'll fix in the next session. Till then, happy coding.